This is, let's say, a simulation exercise. This is a programming challenge. This is not something that you could use for in factory automation or process automation or something. It's just programming. Of course, you could use it because this has to do, we have a string and we want to encode it Morse and decode it as a Morse string. So there's a lot of timing and finite state machine involved here in the programming. And you also get some programs that you can use. Let's see if we have a little look here. Here's the exercise, and we're down here. This decoding, the Morse decoder and so on is in the system here. And the exercise, you should program this encoder, and this ASCII character string to Morse is a function block in here that you can use, that you can inherit, and just put in an ASCII code, and then you get back an array with Morse code with dashes and dots and an end of these dashes and dots, because the Morse codes, I think, is up to 8 dashes and dots and something in the Morse code, so a mixture of dashes and dots. Okay, so this is the function you should write, make an instance data block and so on. Learn how to use to program an advanced function block. This is going to be kind of time consuming to program something like this. Of course, there is a solution or suggested solution. So this is extensive timing in a function block. Use the PLC simulator. Yeah. Embed the ASCII Morse function block for ASCII Morse code encoding, and this how to call it. Observing data in the simulator instance, data block on a simulator HMI. The simulator HMI is just a string, basically. Copy to this document handed in. Equipment is PC, laptop with TI portal, PLC simulator, and a couple of screens, so it can work a little efficient. Program test. You have to program this function. Test the Morse code using the Morse decode, which is included in the simulator already configured. And here is a tag that you have to connect to the output from your encoder, where you have the dashes and dots and so on to test it. And if you code this right, the decoder is working for capital letters and numbers, I think, and something like that. If there are numbers the decoder doesn't understand, the decoder is just going to skip out. So program listing, document the program listing. Here's a little information. The Morse codes, here are dots and dashes. So what they call it, we call it dots and dashing, short and long sounds. You know, this used to be sounds, do-do-do, dee-do-do-do, and so on. And here are the letter codes that we should code. And here are numbers, 1, 2, 3, 4, there's only 5. There are more Morse codes too, but we're just going to react to, there are special characters and so on, but we are just going to react to capital letters and numbers. Of course, we could do more if we wanted to. So this has this additional Morse code for special characters and characters group. Alphanumeric messages audible or visible between locations. What we could connect is to a sound output, and we have the do, or we could have a light that we could look at. Okay, what we are going to do, we are just taking the output internally and connecting to the decoder. Short dot, long dash signals. The base unit signal duration is the dot, and the dash is 3 dots. Space between the dots and dashes in a character is 1 dot, and the space between the characters in a word is 3 dots, and the space between the words units sentence 7 dots. A spacing is absence of sound or visual signal. That's a spacing. So those you don't not output again. Your output is false. And this taken from this International Morse Code World 2022. This was taken. I haven't checked it. It's probably still there. So the code, you have to look at this. This is a dot period to a time. It's 100 milliseconds should be a parameter. Get the first character. Case here. Get a code array with codes with dots and dashes in an array. and use integers in this array, and an integer code for a dot, integer code for a dash, and then you need some end of array indicator, because if you look back here, up here, the A is just dot dash, and then you need an end of character. Say, okay, the A, it is an A, and we have to just these two, one dot, one dash, and a B, a 4, and then there's an end of character. The one system that has made has spacing for 8 of these dash and dots codes. So yeah, set code array dash dat dash. Of course, you could use a case and have capital and lowercase a's, uppercase and lowercase a's if you want to, but the decoder is only working for capital letters. But you could do this, of course, but the decoder wouldn't understand these lowercase letters. And here is a little case for code array start code array end. This array you get. If it's a dot, set the signal for 1 dot period. So wait for 1 dot period, and you're done. Get the next one. If it's a dash, you should have a signal of 3 dot periods, and wait for 1 dot period. 1 times dot period. And if it's a 0 code or any other code or anything, wait for 3 dot periods, because this is a spacing between the character, and then it's just an exit 4 here too. So you loop through here until you get the end of character. I think you can use a code of 0, for instance, and 1 for dot and 2 for dash, and exit 4, you are done. And then get next character out of the string one way or another. The case again, get a code array, and here you go until you get to then wait for 7 dots period if you want a space, and end code means the carry return, or this carry return on a null terminator, that the string is null terminated, which is hexadecimal 00. Then you are done. End your program and wait for another enter or start to send a string. Basically what you should do is enter a string and push execute or something, and then transmit the string and wait for next string and next execute, and so on. And here is the ASCII character, but this function block that you can embed yeah. So what it does, it just gets this decimal code for the ASCII characters, and returns this code that you can use in an index in this array with the embedded function and get this coding array back. It's just for information, rudimentary pseudo algorithm for Morse decoding. And here is a string, and it works in a special way, but here it just decodes the dash and dots and gets an integer and looks into a decode string and just fetches the character here. And these spaces here are illegal ones. So this one can only decode capital letters and the numbers if you look into here. So that's what it can do. And the string could have been extended for lowercase character and so on to do decoding. Basically, that's what the decode here is, the string. Measure time, adjust index, and here's the way you adjust index depending on dash and a dot, and this string is organized so you end up an A, a dash and dot. The index would end up here. I think it starts in the middle and goes back and forth. You can find this way of decoding Morse code on the internet. You can probably ask ChatGPT for something. This is just, let's say, pseudocode for this. Okay, program tips. You need some index, state machine, store, code array index, input string array index. This is a string, and you can handle the string. This is a character return string, and you can handle a string like an array. So you can index to get the character. Just increment this index here, this ASCII array index, and get a new character, and then here you get an array back. This code array with integer with the codes, and the codes here. What do you use? One is a dot for the code, and a dash is 2, and maximum was, that's just the maximum here, how many dashes and dots we can have. And then we have the end of coding array, which is a 0. So this function basically enters dashes and dots as a matrix, and then it zeros in the rest of arrays. So you just output dots and dashes until you get a 0, and then you are done. Yeah, and here's the state machine: get current letter code, get Morse code, output pulse, pause. Yeah, and this Morse void and end of character that you have in your program. Yeah, the void -1. I think maybe the decoder and the void or something -1 as an integer, but you can do whatever. You can look at this function block and check out how this one works, what it returns. Yeah, remember it's executed cyclically, so you should output a dot, restart the program in the state machine, wait till the dot has been output, and then go on. So you just do one operation, a dot, and wait, a dash, and wait. Oh, okay. Here is the timing. You can use this long time tick, and the restart should probably handle. And here is the output, the TBY that you're going to write out. And here are some of these temporaries that you have. So the base is the dot, which is a parameter, and the coding pace, the pause, that's just a dot duration. Dash duration is 3 times dot, and character spacing is 3 times dot, and the word spacing is 7 times dot duration. So this is a space, basically. Yeah. And then we have to hand restart upon restart. So you can read this for the tips, and here's the execution trigger that you should start to decode in idle state, get letter code, look up, use the string as a lookup, maybe a maximum string length, so you're not accessing a string that's too long, but just maybe look, get if you return a carriage return or a 0 terminated string, 00 hex, like this. Just make sure that you end this, so you are not going outside the string, then your PLC is going to stop. Yeah, and here is how you get it. So you input here is a decimal number for the ASCII code, and what you get return is this coding array with 8 integers that you are the dashes and dot codes that you have to output. Let's get Morse code and so on. Output, set output to true if the pulse time duration has elapsed, that you calculate based on what you have in here. Basically, you set the duration to one of these that you have calculated dependent upon what code you are going to find in this array. Yeah, reset timing system and so on. So this is just something. Write to the outputs, and here is some write to outputs maybe. Again, this output here that you output should in your program be connected to this QB Morse output, which is an input to the Morse decoder. So that's something that you have in this program, exercise 06 main, that you're going to make. And the simulator here, which is the decoder. So if you make this right, you enter a string here. If you double click here, this is not in the simulator. You only get this. This you would have to make yourself, but you can also do it in instance data block. And this XE that you have transmit text, and then if you've done it right, the text is going to be written here, and here is the ASCII character that you are receiving, the last one. And so hopefully you should get something here. You only capital letters and numbers, because that's the only thing the decoder can do. Yeah, there's no operation. The Morse code string that's read is shown on the screen, and the ASCII code for last character too. The Morse decoder has the following instant data block. What's important is that the P dot here, this one, has to be the same value as for the encoder. They have to work with the same dot identification. And when you know dot, you know the dash, and you know the pause and 2. So this one is waiting, and so if the pause is 7 long, then it just inserts a space, because that's a space, and so on. And when it gets a 3 dot pause, it knows now I'm going to listen for a new character and do a new lookup in my table. So here it is. Morse code is listening for changes. Now this one, this is from the PLC timetable, and here is what it is in this Morse program. So input to the Morse decoder is simple. He gets this Morse output. So these are square waves, kind of a dot and a pause and then a longer one and so on. So it's being output. So that's pretty much is through this one. So it's not something you could use for control. But you could port maybe this code to a Raspberry Pi or something, and then you could do Morse coding with lights and light sensitive transistor or something. So then you could use Morse code to transmit messages between you and a friend or something like that. It's pretty useless, this stuff, but there's a lot of fun programming it, a lot of constellations that you have. There's lookup into strings and so on that you should do. And here you should probably use the help system for TI Portal extensively to get to do this, and expect to spend quite a few hours coding this. And of course, in the end, you get a suggestion for FB Morse encoder, elegant or not, that would work. So you can look at let's say, at a suggested solution. There's nothing right or wrong here. As long as it's transmitting the codes, you can do whatever. But try to make it like a state machine and make it easy on yourself when you try to program this.